Where is this function continuous? Well, where is it not continuous? Let's find out where it's not continuous, and we'll classify those points of discontinuity. What we have is a rational function. We know that the bottom can't be 0. Let's begin by factoring the top and the bottom. There is no greatest common factor anywhere. By the minus up top, we know the signs are different and the factors must subtract to give us negative 11. Okay, well that's a negative 16 and a positive 5. Looking at the bottom, we have a plus at the back, so the signs are going to be the same. The factors of 15 with the same signs, both positive, must add to make 8. There they are. Oh, let's say it again. One more time. Oh, there they are. So now what is not allowed? We can't have 0 in the bottom. Set the bottom equal to 0 and solve for what's not allowed. Well, negative 5 is restricted from the domain. X can't be that. Negative 3 is also restricted from the domain. But notice that there is the common factor between the numerator and denominator. Because those x plus 5s are repeated factors, we say that there is going to be a hole at the graph, or on the graph, at x equals 5, negative 5. Now that hole is what we call a removable discontinuity. But this negative 3, well, that stays. X can't be negative 3. We're going to see a vertical asymptote at x equals negative 3. Look, just for fun, let's take a picture of a lazy graph. So the graph cannot go here. Sounds like I got mail again. A lazy graph would get really close to negative 5, no touching. There is an open circle there. Continue on. And something else is going on over here. Not real sure, but let's just make a nice curve. Now we can see I've been naughty. I have not taken into account my horizontal asymptote, my y-intercept, any of that. We're only looking for where there's any kind of break in this graph. Let's go ahead and sum it up. We do have discontinuity at x equals negative 5. There is a hole that is removable. We do have discontinuity at x equals negative 3. We see a vertical asymptote there, and that is non-removable. What about continuity? Where is this function continuous? It's continuous everywhere else. That is, from negative infinity up to negative 5, don't include it. Also, from negative 5 until negative 3, don't include those boundaries. And then again, from negative 3 to infinity. Our job is done.